Good morning. This is CodeRage 10. My name is Olaf Monien, and I'm gonna tell you today how to create a push-enabled mobile app with Parse, Delphi, or C++ Builder. First, let's have a look at push notifications in general. Push notifications are basically text notifications sent from some sort of a server infrastructure to your devices. Devices could be mobile devices like iOS, iPhones, iPads, or Androids. Technically, push notification could be sent to desktop operating systems as well, like Windows 8 or 10 or Mac OS X. For some reason, the APIs to those desktop applications are still a little bit weak. They are basically not supported in Delphi, so we are focusing on mobile devices today. This is also the reason why I'm going to create the demo application in FireMonkey. Now, what exactly are remote notifications? Well, it's basically some sort of a text info that's being sent from a server. So it's always coming from a server. It's not coming from a device. What are notifications usually used for? Well, it's to display information while your app is in the background or while your device is locked, like in the screenshot to the right. So it's also about polling and immediate display of information. If you didn't have the ability to receive push notifications, you would have to apply some sort of a polling mechanism to, let the user know about certain events, information which is available for him on the server. You would have to poll the server all the time, which is basically not a good design. Just think of a doorbell. If you have a delivery at your door, the postman just rings the doorbell and you hear the bell and you can go open the door and receive your package. If you didn't have a doorbell, well, you would have to run to the door every 5 minutes, maybe 15 minutes, or maybe every hour, which is obviously bad. But that's what polling would be about. You would have to run to look if there is anything at the door every time. So, push notifications are sent in a way they are pushed from the server so that the device receives them immediately. So they are sent to a specific device. It's not sent to, like a broadcast mechanism. They are sent to exactly those devices that you define the notification to be sent to. They all ring the bell. Well, they are displayed on the device immediately, and they deliver the server-side information to your device, to your user. Important to notice is that push notifications have the capability to store themselves in the system, in the server infrastructure of Apple or Google. So they may have an expiry date. So if you're subscribed to some sort of stock quotes, it wouldn't make sense to receive notifications that are 5 days old just because you were somewhere in the woods on vacation or something, and once you go online, get your device back connected, you would receive all those expired information, useless information. That's the reason why there is usually an expiry date for offline notifications. So let's have a look at the architecture that you would have to apply to make your devices work in the push notification infrastructure. There are two major service providers. It's Apple and Google. Both have different implementations of their push notification systems. There is the Apple Push Notification Services, APNS, and there is Google Cloud Messaging. Both are hosted on massive server infrastructure, and your server, your actual application server, needs to implement the Apple APN protocol and or the Google GCM protocol. So you definitely need a server because your server needs to communicate with, Apple or Google. You never communicate directly with the devices. It's always Apple or Google sending the push notifications. and they are using highly efficiently working mechanisms to ensure that the push notifications are really sent basically in time. There is no real delay. You can actually send those notifications and just a second later you see them on your devices. So by implementing two different protocols and the need to have your own server and to, well, read through all the specifications by Apple and Google, this might become a little complicated task. It's possible, of course. There are many examples of applications doing exactly that. But there's a different way. There is Parse. Parse is something I'm going to show you today. It's what we call a backend as a service provider. So it's basically something in the cloud. It's a provider that hosts servers for you as a service in the cloud. So it's similar to Kinway.com and others. All those providers operate on slightly different business models, but many of them, well, provide you with the needed infrastructure to store data and to send push notifications. I chose Parse for this demo and for applications that I'm working with, basically because they have an easy pricing model. You can start your application with basically no fees. Only when your application becomes successful, so if your business model is really working, you might be well, forced by Parse to pay something for that. Of course, it's supported in Delphi 10 Seattle, and Parse offers multiple services, among them push notifications. That's the focus of today. They also offer storage, so you can basically store, well, objects that you need to run your application to make information in your application, in your apps, persistent. You can even run code on the service they offer. That's not the focus for today. And of course, they have stuff like analytics, and least but not last, they have a flexible REST API. The REST API is used by Delphi. There are components for the REST API. And of course, even they have native APIs, like for iOS applications, there is an Xcode package, and for Androids, all those, well, native APIs are technically going through the REST API. So that's what we are using behind the scenes from Delphi. So how does Parse work? Well, it's basically before the push notification providers of Apple's and Google's. So you talk to Parse, and Parse talks to Apple and Google Cloud Messages. They are implementing the protocol, the services that you need to well, communicate with Google or Apple to have those two guys send the notifications to your devices. And Parse also has storage. That's something we're going to use today in the demo application. The difference between using APNS and GCM directly is that you don't need to have a server, your own server. You could even have a simple application model that just runs on your mobile devices, and somewhere maybe an administration app which is just sending push notifications while some operator thinks that he wants to send out some information to your users. So you don't need to run even your own server. Okay, in this demo we are going to see today, we are just using that model. We only have an app. We don't use our own server, and we are talking directly to Parse. The demo application I created for this session is what I call a walkie-talkie. A walkie-talkie is, well, what it is. You can send messages. We are sending those messages to Parse, and Parse sends out a notification to all the devices, and the devices receive the notification that there has been sent a message. And on the other hand, once the message has been sent out, the other users can just reply to those messages by sending their own messages, and the other devices are receiving, again, notifications that there was a message. So it's a simple chat system, if you will. All right, so this is what we're gonna do today. So let's have a look at the code. All right, so let's see first how the application actually works and, well, play around with it. Okay, I prepared my actual iPhone. So this is not a simulator, this is the real iPhone. I'm using a software called Reflector to present my iPhone to my Mac computer screen. So, and in the background you see there is a Delphi application, Walkie-Talkie, and I'm running the Walkie-Talkie app in Windows. Running the application in Windows still works, but we can't receive push notifications, but we still can send push notifications. So this is the Walkie-Talkie app on this side. As you see, I already tried a little bit and played around with it. And let's start the Walkie-Talkie app on the iPhone. All right, so you basically see the same application running on my iPhone and on Windows. So the idea of this system is that I have chat rooms like Broadcast, Delphi, FMX, VCL, and a lock screen. So I'm just using the Broadcast chat room, and I'm sending hello from CodeRage 10. I click the send button, and you see in the background that there are, and you see received hello from CodeRage X. So the application received the actual push notification and displays something. So we can still, we can actually click on the refresh button here to load the chat history. It's just a demo application. You can do whatever you want with it. It's not a production application. So technically, we are sending push notifications from a Windows applications and distributing them to all registered devices that are using our Walkie-Talkie app. The same thing would work with my actual hardware device. So I'm just typing hello again in that application. It's actually on my real device, so I'm not typing on the keyboard on my Mac. It's the small keyboard on. So broadcast send hello again. Well, I said there is no way, for now at least, to receive push notifications on Windows applications. This is the reason why we don't see that here over in the Windows application. But we still can load the history of all the push notifications from Parse. So we are storing the push notifications manually or persisting them using Parse object storage. So let's have a look how that actually works. All right, this is my virtual machine where Delphi 10 Seattle runs. This is the Walkie-Talkie application, and what we see is the main form. The main form is just a FireMonkey application form, so, well, nothing really specific here. The actual logic is in a data module. I put everything into a data module which is not really related to the user interface, basically for the sake of having user interface and logic abstracted. So what we need first to make our application capable of receiving push notifications is dropping a couple of components on the form or the data module. So the first thing to start with is a parse provider. A parse provider basically connects to Parse and puts in all the information that you need to log in into Parse. What do we need to log in to Parse? Let's have a look at Parse. So Parse is, well, parse.com, and in parse.com you can basically set up your application. You see I have two applications here, HD Mobile and Walkie-Talkie, and once you're inside your application that you created for free, which is the default model, then you can go into the settings of your application, and somewhere down here you basically need to provide some information about Apple. The first thing is to connect to Apple push notification servers. So here you put your so-called Apple push certificates. Apple push certificates are something that you would create inside the Apple Developer Portal. The Apple Developer Portal basically has a page for setting up certificates, identifiers, and profiles. So you have to go through all the all the steps that you would need to set up a mobile app for iOS, and then create what they call APN production iOS certificates and APNS development iOS certificates. Those certificates are created like any other regular iOS development certificates, and you can just download them, and once you downloaded them, you basically upload them to Parse. So Parse uses your Apple push notification certificates to identify itself to be, well, allowed or authorized to send push notifications in your name, in the name of your application, the application that is hosted, or the back end of your application that is hosted on Parse infrastructure. The next is receiving or setting up the keys, basically the authentication mechanism that you are going to use to put that into your Delphi application. So when you go up here to keys, well, let me shrink my screen a little bit so that not every single key is published in this video. When you go to keys here, you basically see all what they call application keys. So the keys we are interested in are the application ID, the REST API key, and the master key. Those three keys we need to copy and paste into our Delphi application. So this is what I did here. So I put into the Parse provider my application ID, my master key, and the REST API key. All right. So the next thing to do is to put the push events component on the same form. The push events component basically connects to the provider, and what I recommend is deactivating auto-activate and activating auto-register device. What this does is it basically sends all the API calls to your iOS device or Android device that are required to receive what Apple calls a device token. This is something that identifies your device against Apple. So that's the way how Apple knows where to send your notifications to. So the next thing is, let's have a look at the startup of the application itself. So we go to the main form and go into the actual create of the application. So let's go into the form create first. In form create, well, there's a logging mechanism, just ignore that for now, and we're setting up some callback functions here to display a status, to display a message that has been received in the UI, and to subscribe to channels. And this is something which deals with the virtual keyboard on your devices. So I'm basically disabling the toolbar menu on iOS devices, which are shown on newer iOS versions. So this is just unrelated to Parse, just some setup of the actual application. So let's go to the form show event. In the form show event, we do two things. We start push services, which means, well, register our device, receive a device token, and get ready to receive push notifications. And then finally, we refresh our chat history. So let's see what start push services does. This is something which is implemented in the data module. So, well, I'm sending a status starting up. You might have seen this little label at the top of the application. This is just to show that. So what I now do is checking what platform are we running on. And I'm explicitly checking for Android or iOS. So once we are running on iOS or Android, we try to activate push events. So we know what we're doing here. Push events means, or setting them to active means, well, make your device ready to receive push notifications. On Windows, this just don't work, because on Windows it's just not supported, well, yet. When we are running on a device different from iOS or Android, such as Windows, we are just, well, able to send push notifications, but not to receive them. All right. So in the on show event, we saw the two routines that are setting up the whole mechanism. So let's go into the other mechanism that basically refreshes the chat history. The chat history is something we will look into just briefly here. What we do is basically ask our data module to get a chat history, however that works, and display it well, in the UI. This is now code that might look weird at first because it uses something we have not learned yet. It's something I'm gonna tell you how to work with in my other session that is about, well, the new threading library, which is system.threading. So we are using task to run things in the background, because getting the chat history means our data module is going to talk to Parse, which may take a little while. And as we are running on mobile devices, we need to make sure that everything that takes this little while is executed in a background task. So for now, just ignore that there is a task run something and that there is a thread queue something. Just notice that we are, well, trying to get our chat history, and once we get that, we are iterating through the chat history and, well, basically parsing the actual messages into the right chat rooms. So we basically get a list of chat messages that have a channel assigned. So something we can do with Parse is sending messages and telling the system to send them to a specific channel. Channels could be like here in our demo, Delphi, FMX, VCL. So we have channels for information around FMX, channels for information just around VCL. So Parse is something, or Parse keeps track of channels. It's nothing provided by Apple. It's something you would have to create yourself if you would talk to Apple push notifications or Google Cloud Messaging yourself. Channels is a very convenient way to send specific information to your users. Just consider a news application that has sports, well, politics, and whatever. So if a user or a reader is only interested in sports, he would only subscribe to the sports channel. And that's something that those channels in Parse are useful for. So this is basically just setting up the UI at this place. So to receive push notifications, the only thing we have to do is to go into the form show event and check this start push services routine. So just by setting push events, which is connected to the Parse provider, which has our application keys, make the application basically capable of receiving push notifications. How does this work now? Of course, there are events. So we can look into the events of the push events component. So we have a device registered event, a token received event. Those are basically infrastructure events. So if you start the registration process, like we have seen here, push events active is true. That sets up the whole thing, and once everything is working, we get those registered and token received events, which we are not interested in right now. But the interesting thing is on push received. And if you look here, there is the actual place where we get the push notification into our application. So here I have a dispatch received message routine, which centralizes all the mechanism that, or the logic which is needed to well, parse the message. So what we do here is we basically look for a chat message, which is an empty object. That's an object I created, a class that I created to keep track of all the information. And I look into a message. A message is push data. Push data is a structure that has things like extras. Extras could be something that we are attaching, a channel. So if there is a channel, we parse that channel value, which is a text string, which could be, for example, Delphi, and connect that to our message. And if there is no channel attached, it's implicitly what I decided to be a broadcast, which is sent to every single device. It's not really a broadcast. We are sending it, or telling Parse to send to every registered device, and Parse goes and takes every single device and takes the device ID and sends all those device IDs to Apple. So it's very convenient to work with Parse, because we don't have to deal with all those device IDs and stuff. And if we have a display message procedure, then we display the message. So we basically just parse the content of the message down here, and then we display the message. Well, I just noticed that I had this single line wrong here, and I corrected that line to actually parse the message that we get put in here in the event. So there is a message property, and that's what we parse into our own L-message object. And then we just pass this L-message to our display message proc. The display message proc is something that I created in the data module, and I created it as a property of tproc of type tchatMessage. This is basically in a way to avoid that the data module knows about the form. Only the forms should know about data modules. So when we start the whole thing, we assign a message to display message proc, which would handle displaying the chat message. We can just check that in our main form. And this is display message here. And you see it's a parameter of a message of type tchatMessage. And well, it's just looking at the message. If the channel is empty, we just put it to the broadcast system. Or if it's a Delphi FMX or VCL message or channel, then we put that message, append that to the actual memo where the messages are displayed. All right, so this is basically receiving chat messages or receiving push notifications, which we use as a transport mechanism for our chat messages. So this is basically everything, but the system only works if we can send chat messages or push notifications. If you start your application, you could actually try to do that from the Parse workbench. So when you go to your Walkie-Talkie app, just go to push, to the push screen, and there is a convenient way to test your actual application. You see all the sent push notifications, and of course you can say send a push. Send a push sends, well, push notifications to a specific audience, here in this case to everyone. And as I told you already, Parse is keeping track all the registered devices and sends the device IDs to Apple to get the push notifications delivered. So we could now create our own message and send that to our device. This will simply work. And what we have seen until now is sufficient to receive the actual push notifications on our device. So what do we need to send push notifications from an application? It's certainly not the typical way to have both ways in the same application. Usually you would just receive push notifications, but for the sake of this demo, I put in sending push notifications as well by entering text in this edit and hitting the send button. So behind the send button there is the actual logic that sends push notifications. So what we do is, well, checking where we are in the broadcast, Delphi, FMX, or VCL tab. And then we just call DMain send message and provide the actual message and the channel that we are sending to. All right, so let's have a look at send message. Before we look at the code, let's have a look at the actual data module. There we have a backend push component. This is the component that also connects to the Parse provider. So this one is connected to the Parse provider and basically has no specific properties here or events. It does have, of course, the provider property. That's what we need here. So let's look at the code. So it gets a text and a channel. So what we do is setting up our own objects, filling them with the proper values. So we put in the message, the alert, which is the same thing in our case, and we are using the default sound for Apple push services. Then we set up the channel, and then one little trick is to attach to the message itself. So the message, the push notification message that gets delivered to the device, we are adding an extra. It's custom. So this is nothing that you need to do, but it's convenient in our application. So we are adding the actual channel that the chat message has been sent to by adding an extra. Extra is a channel, well, and the actual, well, value of the channel. Then we need to poke around a little bit to set up the right format. This is something you just, well, copy and paste from this demo, of course get all the source, and make this the way it is here. So we need this push data object. And we are attaching a date stamp, a timestamp, and there is basically just a differentiation between broadcasting and pushing to channels. If we are broadcasting, we are pushing our message to devices and to all the devices, to iOS and Android. That's the easiest way to send messages to every single device. So this is Parse API push to devices, and well, put in this fancy little push data object we created in this line of code. And we are, of course, keeping track by setting a status message. And if you are sending a chat message to a specific channel, we use Parse API and say push to channels. And of course, you can see this is actually an array, so you could send to multiple channels if you like. In our application, it's just one channel we are sending to. And here, of course, we show a status again. So this is all you need to do to send out push notifications from Windows or mobile devices. As you have seen, the application runs on Windows and we can successfully send push notifications. What I do in addition is using the store mechanism that Parse also offers. So I'm storing the message in Parse just to have a history of all messages for users that just come into the chat room and want to see the history of the chats. So to use that, we just go into that routine here and go back to the data module, and we need backend storage. The backend storage component is also connected to the provider, the Parse provider. This is basically all you need to do here. And in the code itself, it's pretty straightforward. You just say backend storage 1, storage, create object, chat message and put in the object we are trying to store. This is really very convenient because this is the name of the table if we are thinking in SQL relational concepts. But this is what they call a collection name. So we are putting in the content of an object into a collection that we just call chat messages or chat message. So how does this look like on Parse? On Parse, we do have core. Just let me pull that up. And in the core, we actually have those, we have the chat message data. So here's data, this is standard stuff, and this is something we just created. So it's you don't need to create that on Parse itself. So there is no tool that lets you create those tables. It's not really a table, it's a collection. And you could still say, okay, add the class chat message, but if the class does not exist yet, or the collection of that classes does not exist, it will just create what you do here. So if you just send that the first time, it will create that class on the Parse side. So, and you see all the messages I have sent in the past already. So this is our message here, and we store that like in a SQL table. Again, it's not a SQL table, it's basically a class with multiple properties, so slightly different. It's a document-oriented way of doing that. So that's what we do here. And of course, we need a way to check what's already in the history. So let's have a look at the main form again. And you might have noticed the refresh button, and there we have refresh chat history. Refreshing chat history is something I already showed to you in the beginning. So just to rephrase what I already said, or to make it more understandable now, what we do is here call get chat history, and that's where the actual logic is. So the logic is that we create an object list of tChatMessage objects. Again, tChatMessage is a class that I created. And we put that, and we also create a specific tBackend object list. I could work with tBackend object list as well, but I prefer having just plain object lists. So that's the reason why I create the result as a plain tObject list, and then go to backend storage. That's the component we have on the data model, that one. And say storage, query objects. And we are querying tChatMessage classes. That's what we want to receive, and we have to tell, okay, that's the name of the class that we are storing or looking for on the parse side. And then we put in an expression. This is a parse expression. So we have order by date sent. And this minus tells us it's descending. So the youngest message first. And limit this to just 8 messages. There is a great piece of documentation on Parse how those expressions work. This is something you just need to figure out on your own. And then finally, when we call query object, it will put the whole thing into our lchat history object list. And this lchat history object list is basically a tBackend object list. So this is something that is specific for backend for Parse provider. And I don't want that. I want just a plain tObject list, which is the result of this function. And so in that way, I'm just using a for each loop, and well, just reassigning that to our actual tObject list we just created over here. So this is then the way the application stores everything on the Parse storage backend. So we have a chat history, and we have push notifications that we can send And finally, let's have a look at the Windows application again. Okay, the Windows application is here. Just let's run the Windows application and see how it actually loads the chat history. So let's go over here, and you see it basically went through the objects in Parse. So let's see, here's hello again, hello from CodeRage X, and we should see that in Parse itself. This is sorted. Hello again, this is the message here, and this is hello from CodeRage. So this is the way it works, and well, I'm basically done, and it's up to you to ask questions. Thank you.
Unfortunately, Olaf was not able to join us for Q&A, but I can go ahead and answer most of these questions for him. First question is if Parse works with the latest iOS from Apple, iOS 9. And yes, it does work with iOS 9. And also the great thing about Parse is they have a really great free tier that provides lots of push notifications and API calls for free as well.
Can we use other BAS servers other than Parse.com? Yes, you can. We include with Rad Studio Parse and Kinvi BAS providers, but there's also, I think there's another one, I think it's called App42, that they have created components that you can download that you can just install for App Method or Rad Studio. I think they specifically target App Method, but they'll work with Rad Studio as well. So once you install those components, then you'll be able to connect to their service. Or you can extend it for your own if there's a different service provider you want to use. So if there's a different one you want to use, you can do that as well. TMS might have some components for connecting to different providers. So Dante's asking for the source for the walkie-talkie example. I have a copy of Olaf's source here, so I'll go ahead and I'll upload that to Code Central later, and I'll push it out to our update page. So here's a question. Can you store a database, Firebird, on the Parse storage or Kinvi and connect to this via FireDAC? So the way Parse and Kinvi work is they have their own data storage, and it's based on, it's using MongoDB on the back end, but you're not connecting to it via FireDAC. You're not connecting to it as a database. You're connecting to it through the Parse and Kinvi APIs through the back end of the service providers. So it's becomes a document storage. It's not a database at that point. Well, it's a database, but you're not interacting with it as a database. So you're not going to use FireDAC. So now you could technically take a database and store it in Parse or Kinvi as a document, but you couldn't connect to it that way. You'd have to retrieve the database from the back end of the service provider, download it locally, instantiate it, and then connect to it. Okay, so once you've stored it in Parse or Kinvi, it's just a document. It's just data. Okay, you're not running it on their server. If someone using a Delphi app push notifications to use transfer information capsules like objects of certain known classes. So could you use push notifications to transfer information? Yes, you can. There's additional information you could include in the push notification that could be JSON, for example, I suppose. User. So as far as sending to a specific user, you have to provide a query criteria, specify what users you want to send the message to. And then once you do that, it will send it to users that match that criteria. So as far as being able to send to specific users, you have to do that. And Parse and Kinvi have documentation on their server explaining how to do that user matching, and then you can just embed that in the push notification request. So there's a question exactly what is a BAS server? A BAS server is a backend as a service server, and so the idea is you could build your backend using DataSnap. And so you could build it from scratch, your entire backend implementation, and then host that yourself. Or you could use EMS. EMS is our turnkey backend as a service, or MEEP is what the terminology is. And it works out of the box. You just turn it on, add some modules to it. It has user authentication, as support for push notifications, etc. Backend as service is where instead of building it yourself and hosting it yourself, instead you pay Parse or Kinvi, and they will host your data and provide the services you need as far as user authentication, hosting the data, brokering push notifications, etc. So the idea behind a backend service is where you are paying somebody else to host and manage the backend as a service for you. So they maintain that service so that you can then connect to it and send push notifications, store data, authenticate users, etc. Is push notification often used for support by sending messages back to developers or a support group? Could be of interest to give support directly to in Delphi IDE. So a push notification, if I understand what you're asking, Alf, it goes the other direction. The idea behind a push notification is when you want to let client apps that are running on mobile devices know about an update. So yeah, it's how you'd push notifications out that way. So for support, if you're like using an app and you're like, oh, something's wrong, you don't need to notify the developer. Doesn't need something to pop up on the screen and say, hey, there's a bug. They would instead have that notification go back into a queue, and then when the developer's ready to look at bugs, they could go to the queue, their issue tracking system, and look and say, okay, what bugs are reported. So App Analytics, for example, gives you the ability to capture exceptions as well as custom events. So you could have a custom event where the user could say, send feedback to the developer, and they could do that via App Analytics. And then when the developer is ready to address new bugs, they go look at the App Analytics feedback custom events and say, oh, a user said that they don't like the color of this button. Okay, I can fix that. So yeah, App Analytics will probably be the better solution than instead of having push notifications going back to the direction to the developer.